Isoprofit line method is the most basic graphical way to solve a linear programming problem. You can graphically solve a linear programming problem only when it has two decision variables. So you can imagine this is not very practical and you're not likely to actually solve a problem using this method. However, this method will give you a good sense about some very important properties of LP problems. Let's look at this problem for example. We can start by graphing the constraints. This will lead to the feasible region over here. This is a feasible region. Each point in this region is a so-called feasible solution. They're called feasible solution because they meet all of the constraints of this problem. So the optimal solution that we are looking for is simply the point in the feasible region that maximizes the objective function. In other words, to solve this problem, all that we need to do is to find which point or points in the feasible region give the highest objective value. Now we can apply the isoprofit line method. The first step of this method is to arbitrarily assign a value to the objective function. For example, I'm going to choose 2100. So the objective function becomes this 70t plus 50c equal to 2100. This makes it a line. Now let me graph this line. To do so, I need to find 2 points on this line and then connect them. For example, I'm going to set t to 0 and solve it, and that means c being 42. So 0, 42 is a point on this line. I can find another one by setting c to 0, which means t will be 30. So 30, 0 is another point on this line. So these are 2 points. Now let me connect them, and I get the line over here. We call this purple line an isoprofit line because all the points on this line will give you the same objective value of 2100. So in other words, we find lots of feasible solutions that give an objective value of 2100. The question is it the best we can get? Can we get higher value? So now let's improve the objective value a little bit and see what happens. Say, let me increase the objective value to 2800 and draw the objective function again. Here's a new isoprofit line. Turns out that the line moves up. It still covers the feasible region. So that means we can improve the objective value from 2100 to 2800 and still finding feasible solutions. So that's great. We can further increase the objective value and the line will move further up. So we find the line moving upward as we increase the objective value. This is an important observation because it implies that the highest objective value in this feasible region will be given by the corner point over here. This isoprofit line that goes through the corner point gives you the highest objective value in the feasible region. So now we know the optimal solution is given by this point. How do we find its coordinate? Well, it's very simple. It's the intersection of the two blue lines. So we can simply solve this simple system of two equations. You solve it, you carry out the algebra, you'll find that it's t equal to 30, c equal to 40, with a profit of 4100. That is our optimal solution and the optimal objective value. Now let me sum up. To use the isoprofit line solution method, first you arbitrarily assign a value to the objective function and graph it. That's how we have this purple line in the first place. And actually what matters here is the slope of this line. Because now you're going to change the objective value and see how this line moves. How do you see that? The easiest way is to plug in the origin point to the objective function. Here, plugging 0, 0 into the objective function, you will get a value of 0, which is lower than 2100. So that tells you as you decrease the objective value, this isoprofit line will move down. In other words, if you increase the objective value, this isoprofit line would move up. Now, with the slope of this isoprofit line, it is clear to see that the optimal solution occurs at the boundary, at this corner point. So the rest is simply to find out the coordinates of this point, and then you solve the problem. So essentially, all that we are doing here is to find the slope of the isoprofit line and find out how it moves. Now you can easily tell where the optimal solution is. This basic dynamic also reveals a very important observation. The optimal solution must occur at the boundary of the feasible region. Also, the optimal solution must contain at least one of the corner points of the feasible region.